Oh, I think we're live. Hello, this is Mr. Bourgeois from Trinity Classical Academy, once again, back in the saddle. This is just a little bonus video to help solve number 16 from the Math in Focus, Chapter 3, Test B, that we some of us did in class, maybe all of us did in class. I just wanted to demonstrate it real quick. I was having a hard time solving this problem without using algebraic equations because that's a chapter 4 concept, and I just don't see a way to solve this. I didn't at first, let me rephrase that. I did not at first see a good way to solve this without using chapter 4 concepts, and so it was really stretching for me to try and figure out how would one of my 7th grade students solve this problem if they haven't been equipped with the power of algebraic equations just yet. And then I started to just play around with it, and then I landed on the solution. So let me show it to you. So if we start with a bar model, so it says there are D horses in a field, some black and some brown. I rewrote the sentence so that it was more clear. There are 16 more black horses than brown horses. Of the horses in the field, 25% of them are brown. So how many are black? All right, so they said there's D horses in the field, so we're gonna call this bar model D. So the bar represents D, and it said 25% of them are brown horses. So I divided mine into fourths because 25% represents a fourth, right? So these are brown. We're gonna represent brown with an R. We'll do BR, why not? Brown. So if 25% are brown, and there's only brown and black horses in here, then we know that this many must be black. So far, so good? So 25% are brown, the rest are black. They also said that the black are 16 more than the brown. So logically, I'm gonna get a highlighter here. Let's see if I can't. There we go. What color are we? I don't know, we'll go with this color. Hashtag colorblind problems. So these are the brown horses, maybe that's brown. And then it said the black horses are the brown plus 16 more. So if they were going to be equal, I would have this chunk right here be the equal, but they're not. They say there are 16 more horses. And so this extra 16 can be represented by this chunk. Now, is it starting to become clear? So if the black are 16 more than the brown, then this chunk, 2 units of our bar model, represents 16 horses. So if I divided it up into our D into fourths to show that 25% are brown, and then I know that that's 4 units. 1 unit is brown, 3 units are black, and that's 3 units, a ratio of 3 to 1. So it's a 3 to 1 ratio. This is a ratio, black to brown. And now it should become clear that 2 of those units are 16, which means 1 unit is 8. So if 1 unit is 8, I just count how many units I have for black, but we already established that it's 3. So we have 8 plus 8 plus 8. There should be 24, 8 plus 8 plus 8, or 8 times 3, 24 black horses. Actually, before I started this video, I should have checked my solution to make sure I was correct. I am pretty sure I am correct anyway. 24 is in the answer key as well. So sometimes I want you to be encouraged. Tomorrow is the real checkpoint. Be encouraged. Sometimes the answer is, well, hopefully often the answer is not going to be perfectly obvious. I want you to just play with the numbers. Don't be intimidated by a problem that looks daunting. Just start drawing it and see if the solution starts to pop out at you. That's what I did. I mean, I would have just used an equation to solve it, but I knew you guys hadn't learned equations yet. So I'm like, what do they know? They know bar models. So using a bar model, you can start drawing it, and then as you start drawing what you do know, what you don't know might start to become clear. Hopefully that is the case for you as you continue to do hard things and figure it out. Problem solving. All right, Trinity Classical Academy, I love you all. Peace out.